Examples. So we should do at least the 3. 1, f of x is equal to 1 minus 2 sine 3x minus pi over 2 sketch. Then its full period. Solution. So we said for this type, this is sine. So we need to get the period, which is 2 pi over 3. 3 is our b in this case. So that's the period. Then the scale period we divide by 4, meaning 2 pi over 3 we divide by 4. So we'll get pi over 6. Then the first shift we get 3x minus pi over 2 is equal to 0, giving us x is equal to pi over 6. Then we sketch. So start from the shift, pi over 6. So pi over 6, that is 30. We add pi over 6, meaning another 30. We'll get 60, which is pi over 3. 60 plus 30, we'll get 90, which is pi over 2. 90 plus 30, we'll get 120. Now 120 in radians, we get 2 pi over 3. And then since there's a shift, we'll add the step. So 120 plus 30, we get 150. 150 by pi over 180, we get 3 there, 5 pi over 6. So I want to sketch within its full period, including the shift. Then now we get back to f. What is f of pi over 6? That's going to be 1 minus 2 sine 3 pi over 6 minus pi over 2. You understand that this one is going to be 0 here, and sine 0 is 0, so we just get 1.
Sir.
Hello.
Sir, okay, what are you adding at first for you to get pi over 6?
Let's get pi over 6.
It's 0.
For you to get pi over 6 is the shift, the phase shift, which is always our starting point. It is to pi over 6 where we add the scale. So if radians confuse you, convert them. So this is the same as 30. 30 is our shift. And we are adding, this is also the same as 30. We are adding 30. So we start from 30, we'll be adding 30 to each number that we get. So 30 plus 30 will get 60. Then to which number next? We add 30 again. So 30 plus 60, we get 90. To which number next? We add 30 again. So 30 plus 90, 120. To the next number, we add 30 again. 120 plus 30, 150. That's how we obtain the x numbers.
Okay,
Sir,
Uh-huh.
so the end part, it will be the period.
So the end part is where we have a full period because the question says the full period.
Now, why not ending at 2 pi over 3? You've added up to 5 pi over 6.
Because we have shifted it by 30.
Yeah, okay.
Oh, okay. Now, sir, that's 120 times. Sorry, I was logged out. That 120 times pi over 180. What is it about? The one that you've written and the.
So we are converting 120 to radians.
Where did the 120 come from?
That was our so the idea here is we want to sketch this, so we need to get points. So how do I get the points? I go to the first shift and add the scale until I get to the end number. So our first shift was 30. So when you add 30 plus 30, we got 60. That was our next number. Then to 60, we add 30, we got 90. To 90, we add 30, we got 120. To 120, we add 30, we got 150. And then we have to convert them to radians.
All right, thank you, sir.
Okay. So now, after getting those angles there, we need to calculate the y values corresponding to these angles. So we start with pi over 6, the first number that we have there. So for pi over 6, we'll have 1 minus 2 sine 0. Sine 0 is 0. So we just get 1. So we have pi over 6, comma 1. We have the point there. Our next angle is pi over 3. So we have 1 minus 2 sine 3 pi over 3 minus pi over 6. This is 1 minus 2 sine pi minus pi over 6. That is 180 minus 30, which is, so 180 minus 30 is 150. So I've converted it to degrees. So I'm using degrees now, 150. So what is sine 150? Sine 150 is the same as sine 30 because they are all in the second quadrant. I mean, sine is positive in the first and second quadrant. So sine 150 is exactly the same as sine 30. It's the reference angle. And sine 30 is half. So we'll have 1 minus 2 half, which is 1 minus 1, which is 0. So we have 0 at pi over 3.
Sir, repeat them.
So pi minus pi over 6, that is 180 minus 30. 180 minus 30 is 150. The reference angle of 150 is 130. I mean, is 30. And so sine 30 is half. Then we look at this, the sign of a sine in the second quadrant. It is positive as it is positive in the first quadrant. So the sine 30 we get, which is half, remains the half even for 150. Because sine is positive in the second quadrant. Then we go for
Sir,
you know,
there on F pi over 3, why did you subtract it by pi over 6 in the brackets?
oh, okay. I don't know. I think I made a mistake. Supposed to be pi over 2, is it?
Yes, sir.
So it's minus pi over 2. Thank you. So we'll have 1 minus 2 sine pi minus pi over 2. So we get 90. So 1 minus 2 sine 90. Sine 90 is 1. So I have 1 minus 2, 1. This is -1. So we'll get -1 instead.
So won't that be like won't it be minus 9 sorry, -9?
180 is bigger than 90. So it will be positive.
Oh that oh that's 1/8. Okay.
Mhm. Okay, the next one we do for f of 90. That is 1 minus 2 sine 90 by 3 is 270 minus 90. So we're dealing with 1 minus 2 sine 180. Sine 180 is 0, so we just get 1. So now when I get 1, okay, let's go to the next number, f of 2 pi over 3. We didn't convert this one, so let's write it the same way it is. So I have 1 minus 2 sine 2 pi over 3. We need space. I'll use this one. So f of 2 pi over 3, this is 1 minus 2 sine 3, 2 pi over 3 minus pi over 2. So we get 1 minus 2 sine 2 pi minus pi over 2. So this is 1 minus 2 sine 270. 360 minus 90 is 270. Sine 270 is -1. So we have 1 minus 2 by -1, which is equal to 3. So we go to 3. So we know the next one will be coming back to here when you calculate. And so for sine, this becomes the graph. This one.
So you didn't finish the one for sine 180. What did you say on that one?
Sine 180 is 0.
Oh, okay.
So we have 1. So that's how we sketch sine. If on this same graph we wanted to sketch cosec, so these are related. On the same graph, if the question was f of x is equal to 1 minus 2 cosec 3x minus pi over 2, what do? You go to the number standing alone here. This number 1. Any point at 1, you put an asymptote. Any point at 1, you put an asymptote. Any point at 1, you put an asymptote, you know?
Before you go further, on f2 pi over 3, is it still going to be okay if we still multiply 2 pi over 3 times 3?
You mean here?
Yes.
And then, what do you mean? Is it going to be still okay if you multiplied it?
because I was using the one in degrees, say 2 pi over 3 it's 270. So
It's
wait,
not 270.
okay, I think I made a mistake in my thinking.
All right.
So what do you mean the number standing alone?
So this number here, the
In-
D, the vertical shift.
Oh, that's where you put your, oh, okay.
That's where we put our asymptotes.
And
So
sir,
for the
just another
confusion of the
question.
asymptotes, you know?
Sorry, you can finish, then I'll ask.
Now you can ask that I included in my explanation.
And now, sir, the pattern for, I thought that these graphs follow a specific pattern. Like, since it went down to -1, it went up to 1. Wasn't it supposed to go back again to negative? Like, it went up this time. So, how come the pattern is not followed?
This is the pattern. For sine and cosine, this is how the pattern looks like. Well, this is just
Yes,
in
sir,
one
that's
period.
how the pattern is. Like, I thought when it goes back to -1, it will go to -1, or like the way was it coming from 3 this side, maybe?
Yeah, just coming from 3.
Okay, I understand then. Thank you.
Okay. Linda.
Yes, sir. So do you mean when we are finding for sine, we don't have to find amplitude or what?
We don't necessarily have to mention it if you're using this method of obtaining the graph where you solve, because in the solving, the amplitude will be taken care of. So it's only for tan and cot that we get to be concerned about the amplitude.
All right, sir. Thank you.
You can finish about the
Sir.
asymptotes.
Okay, so you get to the number that is standing alone, the D, and place your asymptotes there always for any function. For all the two families, that's why you place your asymptotes there. And then for sine, where it is facing up, you flip it down. Where it's facing down, you flip it up. It becomes a graph of cosec.
Sir,
You know?
how you should teach us how to sketch a root, like they've given us a root, like there's this question now, I'm confused on it. There's a root on it. If possible, you can write on the board and then you give us the guidelines on how to go about it.
Okay, so we'll have it in the next class. I think we have exhausted the hour now. Need to go for another course, you know?
I didn't understand what you said about the asymptotes.
So the asymptotes will be placed on the points that are standing on the vertical shift. Remember I said the vertical shift is D, is it? So all the points that are on the Y, we'll place our asymptotes there, because we only obtain them when sine is 0. And so for cosec will be undefined there.
Oh, okay, I see. Thank you, sir.
Okay. Okay. Good day.